This is our model for this year, kind of a simple round part, kind of like the stage, right? So it's a simple round part, it's got some holes in it, and then we make the changeover on the right and ask you to run a quick simulation. Oh, we'll spend a little bit more time with that in just a minute. So way to go, guys. So this is the model, the phase one part that we give you. So as I mentioned before, we give you a drawing, we ask you to sit down and model the part. And then we'll give you a change to make to that part. So a round part, it's got a hole in it, 4 holes on the outside, some pockets, and then it's kind of shelled. The constant wall thickness throughout is 3. So let's take a stab at this thing here. We'll start off with a sketch and just create a couple circles, 65 millimeters, 16 millimeters, and we're going to extrude this. I'm a big fan of using Instant 3D, so I'll just grab that sketch, drag it out 15 millimeters. What we're going to do next is we're going to create a sketch on that front plane. So right on that front plane, we'll create a sketch. I'll use a construction line here, 22, because the bolt circle is 44, and we'll draw a 7 millimeter circle to define the hole. And I'm going to convert that outer edge. That'll help me when I'm establishing relationships while I'm sketching, so this perpendicularity, it helps me establish that relationship. Transition straight to an arc right off the line command, and then we'll add a concentric relationship. I'll also add a symmetric relationship between the 2 vertical edges there as well. Then we'll add our 45 degree dimension, and you don't need a radius on that lower arc there because you can see that that line, because of that perpendicularity, goes through the center. Trim that up, and we'll go ahead and extrude it. I'm using sketch contour, so all I had to do is choose that one outer contour, and I'm able to extrude that right to the back face. Actually, not to the back face, offset from the back face by 3 millimeters. So then what we'll do is circular pattern. I'm going to pattern that around to the bottom side too. That's the way I guessed to do it. Some people did mirrors, some people did different things. It might have caused some challenges. Here I'm going to shell. So I'm going to shell out the bottom and the hole. That still gives me a 3 millimeter hole, but it gives me everything that I want by shelling that face to find the hole. Here I'm just going to access, using breadcrumbs, access the sketch. So I'm going to access that sketch and then use that contour to extrude that hole through all, and we'll pattern that all the way around to the bottom side, or make 4 of those around to the bottom side. All right, fillets. So this is a machine part. If you noticed, all the concave edges were filleted. So I'm going to use the selection manager to choose all concave edges. Kind of a one-button click. It allows me to create all those in one shot. I don't have to worry about grabbing a whole bunch of edges or features or different things like that to fillet that. You don't have to add the color. I like to add the color because it helps me visualize that. Very important, you got to apply the material. In this case here, plain carbon steel. And that's it, phase 1, done. Pretty simple. I don't know how many features we got, 6, 7, somebody's counting, 7 features, not too bad. So, once you're done with that, we give you this other drawing and say, all right, now you got to make a change to it. 4 holes goes to 6. The pockets that are on the front side here in the lower left view go from 2 to 3, and then the shelling in the back kind of takes place. But if you look at that view on the right, those pockets have the edges that go into the center are straight lines. And when you shell that, you'll see later on a way to get around that. And then we define the simulation, which faces to hold and which faces to apply the load. We got those nice bubbles, and we give you the load direction in that center view and the section view. So let's get started on this. Here we go. Let's go and change the number of holes in the pattern from 4 to 6. No problem, no rebuilds. From 2 to 3 here. No problem, everything still looks pretty good. We'll take a look at the back side. And here what we want to do is change our shell. So we're actually going to remove that face. So we're actually shelling that material. And there's some geometry that needs to be filled in, namely around that face. So I could model that geometry, and here I'm just going to choose to use the delete face command, and it's going to delete that face off and repair that and actually patch that up for me. And a real quick, easy way to get rid of that material. So now what we got to do is we'll repair our fillets. Again, I'm just going to clear selection here. This is a machine part. I'm going to run a ball end mill through there, 2 millimeters, and it'll go ahead and capture all those in one shot. So the geometry's done. Now we're going to run our simulation. New static study, pretty straightforward. Those 3 back cylindrical faces, defining those holes, we're going to hold those as fixed. And then the 3 cylindrical faces on the front, we're going to apply a load. And the direction of that load is going to be into the part based off of that front face. So there were a lot of people that that applied a radial load on those holes, and that's not really what we wanted there. 800 newtons per item, and we'll reverse that direction. Last thing we had to do is run it. Then we get the nice pretty plots that show us what our stress is. I like to do an animation to make sure that it behaves as I predicted it to, as I expected it to, and then we ask for the factor of safety. So there's a factor of safety, 2.8, and that's Model Mania for 2017. So that's pretty nice.